Okay, guys, we finished the last one. I know I went through it pretty quick there at the end, but you can see you're not going to have any x value of positive 2, right? Positive 2. I don't know if I said negative 2 or positive 2. There's no value of x equals positive 2 on this circle, right? Think about it. Everything is from 1, positive 1, and to the left. So there's no anything to the right of 1. So there's no solution. There's nowhere that you're going to have an x coordinate 2. Let's see if the algebra backs that up. X plus 4 squared plus y minus 1 squared equals 25. This beautiful thing about math is we should be able to get the same answer algebraically. So I'm going to plug in x equals 2. I'm going to let x equals 2 and see what I get. And plug in 2 there, I get 2 plus 4 squared plus y minus 1 squared equals 25. Over here, I get 6 in the parentheses squared is 36. Use a different color. I get 6 in parentheses squared is 36. Y minus 1 still is over there. I don't need to mess with that. Equals 25. And we're going to subtract 36 on both sides. Remember, we're isolating the squared thing on both sides of the equation. Subtract 36. Gets rid of that, and we end up with our y minus 1 squared equals negative 11. Now, when we go to solve this, we should be taking the square root both sides, plus or minus, outside the square root. But I got a problem here, because we're taking the square root of negative 11. Okay? Now, we are only in this class talking about real solutions. So this actually, what we see, we are graphing on the real axes, the real xy coordinate plane. We didn't have the imaginary plane in here, which you'll get into in Algebra 2. But we're not looking for imaginary answers. So actually, there are imaginary answers, but for the purposes of this class, there are no solutions because you can't have square root of a negative number. Okay? Only imaginary solutions. So you don't need to tell, all you need to know for this class, just write no solutions. Okay? For now, we're talking about a flat XY coordinate plane. Okay? Let me go back and approach number 15 again. This one was probably the more complicated of the three, and we did it quickly in class. But I want to go over real quick. Let's go ahead and graph this. I'm going to graph it really quick. 1 comma negative 3. And a radius of 10, which puts us over here, puts us up here, puts us over here, and puts us 3 more below, somewhere like that. And we've got our circle that looks something like this. I know it's not perfect. Circle looks something like that. Right, we got a radius of 10, center of 1, negative 3. Okay. And we're looking for places on this circle, somewhere on the circumference, where we have an x coordinate of negative 7. Okay, that's the whole problem. We have it graphed. We know where x equals negative 7 is in general, right? Here's our x-axis. X equals negative 7 is 1, 2, 3, 4, 5, 6, 7. X equals negative 7 is here on the x-axis. But if you were to graph all the points where x equals negative 7, it would be a vertical line. Okay? And it looks like that vertical line is going to cross at 2 places, right? And depending on how accurate I was graphing my equation of my line and my circle, could say a lot about how close we are. Now, we talked about in class, I don't know exactly where that is, but I do know the radius, right? The radius of this is 10 units, okay? And I know from here over here is from x equals 1, because the center of the circle was at 1, And if I went over to 7, negative 7, that would be 8 units this way, right? So this is 8. So let me draw that. I know we're doing this graphically, but it's good to see a little bit of what's happening with the numbers. 8 units this way. The hypotenuse is 10. Before you start taking out your calculator and doing trigonometry here, we don't need trigonometry. We're just missing a simple side of our triangle, right? It'd be nice if we knew this distance, because if we knew that length, we could just count up from -3 on the y and count up and find out where that is. So indeed, you could do some simple Pythagorean theorem and find, after you do that, you're going to find that a is 6. So it's 6 units from here up, okay? It kind of matches my graph, kind of doesn't, I don't know. 1, 2, 3, 4, 5, 6. I wasn't perfect. It was up here a little bit, right? So it was up at +3. So one solution was here at -7, +3. But there was another solution down here. It should be 6 units down this way. These two triangles are congruent. So by the same algebra here, we'd find that a is 6 again. This is 6, this is 6. So I got to go 6 units down from -3. You're going to be down at -9. So -7, -9 would be the other solution. So you got one solution at -7, 3, and the other solution at -7, -9. They're both 6 units from where the center was at -3. 6 units up, 6 units down, and 7 units to the left. 8 units to the left. Okay, let's go ahead and do this algebraically. To do this algebraically, we are going to plug in, let this x equal -7 in the equation. I'm going to plug it in. I'm going to go ahead and plug it in to save time. Okay, and this is where you got to be careful with your algebra. Okay, let's first of all simplify what we know. -7 minus 1 is -8. We square it, we get 64. We have 100 on the other side. But we still have this y plus 3 in the middle squared, right? And I want to think of isolating that, okay? I want to isolate this. So let's deal with the other numbers by themselves. And the best way to do that is to go ahead and subtract 64 on both sides. Okay, if I subtract 64 on both sides, I'm just going to bring this straight down, right? Y plus 3, parentheses squared, equals 36. Now the algebra here is we need to get y out of here, right? Our goal is to find out what y is. But it's stuck inside this squared. But that's great, right? Because if this is the only thing happening on this side of the equation, I can take the square root of this side of the equation. As long as I do the same on the left as I do on the right, that's a valid algebra step. With the tricky thing about the square root is you got to remember the plus or minus, okay? So square root of something squared, that something ends up being by itself now. We just end up simplifying that and getting rid of that whole thing. Oh, what just happened? I lost something here. I don't know what I lost. Okay. So we just end up with y plus 3 squared equals plus or minus 6. And I don't know what happened. We're going to, sorry, we got rid of the squared. We'll get rid of that squared. What is wrong with this? Sorry, we got y plus 3 equals plus or minus 6. That means we can now solve. We have y plus 3 equals 6, or we have y plus 3 equals, get rid of that, equals -6. We're going to finish that by subtracting 3 on both sides. We get y equals 3 on the left, subtract 3 on this, and we get y equals -9. Okay, notice these numbers are different. They don't have to be in the one positive and one negative of the same thing. So our x value was -7, so we had -7, 3, and -7, -9, which ends up matching what we found on the graph.